Hello and welcome to another AP Computer Science video. We're going to talk today about loops again, but this time we're going to take it a step further and do something that might be obvious just because of the way we've been writing our code, but we're going to see some examples of what powerful techniques we can gain from. And this is the idea of nested loops, right? We talked about nesting of if statements, which means if statements that might be inside of other if statements, or if statements inside of else statements, or any combination of those things. And the same rules apply for loops. The main difference is that we have to be very careful when putting one loop inside of another, because the amount of work that is being done is amplified by a huge amount. It's not just the kind of, if we were to try to figure out, and we'll do an example where we try to figure out, well, how many iterations actually happen in total, it can become very large very quickly with nested loops, and so it's not something you take lightly. For most examples, small, limited-sized loops that don't iterate for a long time, when they're nested, can be effective, but there are situations where we have to be very careful about what that means in the different examples. So we'll try some things out today and see that happening. So we're going to make a new class in our iteration package. I'll name this one Nested Loops. We'll go ahead and make a main. And the first thing I'll point out is that when it comes to loops and nesting, there is no limitation on can you put a for loop inside of a while loop, or a while loop inside of a for loop, or a while inside of a while, or a for inside of a for. There's no rules against any of those things. You can mix and match as you see fit. And again, it's about the context. Generally speaking, I've mentioned this before, if you have a sense of how many times you're going to iterate, then a for loop is usually a good choice. If you have more of a sense that some condition is going to change along the way and you don't necessarily know when, then a while loop is a better choice. If you need an index into a string, a for loop often is very convenient because we can use that sentinel, the I value, as an index. Of course, you could do the same thing with the while loop, but it takes a little more setup with variables outside of the loop. With the for loop, it's all packed into the header, which is very convenient. So we have to kind of consider what we're going to be doing in our situation. So our first example is going to be very simple, and this is a pretty common one to try out. We want to print out a nice little column or right triangle of asterisks, or any symbol that we might think. And so I'm not sure if I have an output already that has it, but yeah, so these are the two we're going to aim for. The first example we're going to do is going to be a left-aligned right triangle. So we'll say you tell us the height, and we'll generate a triangle of that size. So the height of this one is 5, where the topmost one is only 1 asterisk, and then 2, and then 3 and 4. So if you count the rows, the first row has 1 star, the second row has 2 stars, the third row has 3 stars, and so on. And so we'll maybe make it a method so that way you can give a number and generate a triangle of any size. And so this first one is useful. It can be done with a nested loop, and it's not too difficult. The second version, which is a right-leaning or facing triangle, is very similar, but does take a little bit more planning, mainly because in order to push things over in the console, we must, whether we see them or not, print spaces. And so this is the idea that we're going to be doing that, is that there are, in fact, spaces on the left side here. So if we can pull those both off, those are both with nested loops, and I think those would be good examples. But before we do that, we'll also perhaps maybe generate, another good example is to generate the times table of numbers from 1 to 12. So we know 1 times 1 is 1, 1 times 2 is 2, and then we might get, every row we get different numbers. 3 times 4 is 12, 3 times 5 is 15, and so on. So we would make that times table, which is a grid. And we'll talk about some things to make that happen. And again, in this example, loops are very useful, and pretty much the only way to do it without really being extremely expressive in our code. We can limit it to very few lines and generate a pretty big grid. And again, the size 12 by 12 is actually pretty arbitrary. We can make a grid of any size numbers, and the loops are still effective that way. We're going to go ahead and try that. So what we're going to do is we're going to do this as methods. So we'll make individual methods, and we can just call them in our main. And the methods may print something, they may return something. But it doesn't really matter as long as we create the methods. And so if you don't remember, this is a good kind of review of how we create our method. Every method signature is always the same, or the header always has the same components. So let's go ahead and do one called times table. We're gonna create this method times table, and it will print out a times table where all we tell it is where to start or stop the number. So we'll put it maybe 12 by default, but we can make a larger times table or a smaller one if we deem that necessary. So when we make our method, the first thing we always do is we ask ourselves who's going to be allowed to use it. This tells us the access modifier. So far we've only learned one, and that is public. So we're going to go ahead and put public. We ask ourselves next, do we need the static keyword? Is the context of this method only the input, or is it related to some object or other data that's we've collected? And in this case, so far, we've only really seen static methods, so we're going to put the word static as well. The context is the input and the output, and that's it. Next is our return type. And so we have not seen this before, but we're going to go ahead and show it now. It's a very convenient thing to have. We've essentially we said we could put any data type that we want to return, and we put that keyword return. Well, there's one scenario that we didn't really cover, but it's good to know, is sometimes methods may do some work, for example, printing data, but not return anything. All the coding back questions we've done, all the examples we've done, we've usually returned some data. Could we make a string and return that? We could. Or if we're going to have our method print directly, there's a special keyword we are allowed to put that says, even though the rules say we must return something, this special keyword says, actually, I'm not going to return anything. So I'm going to put this word, and then I'll put a note on top that clarifies why this is, how this works, and we need to know this extra word. And this keyword is void. And we've seen it in main, and so now we've seen almost all the words and all the structures as part of this main function. We're kind of slowly catching them. So void basically means there is no return type officially. You can write code and there doesn't have to be a return statement. There will not be a compiler error if you don't have a return. So you can print something or do things like that. So you don't want a return. And so I'll write a note about that in a moment afterwards. The next is the name of the method. So we'll call this one times table. And then finally, in our parentheses is our parameter list or argument list. And so for this method, we're going to say, well, tell us the number that you want us to go to. And so if you put 12, we're going to do a 12 by 12 table. If you give us 3, we're going to do a 3 by 3 table. So let's go ahead and choose that as an integer because we can't really have half of a row or a quarter of a row or some decimal. So integer is a good choice for our data type. And so we'll say size. And notice there's no error. Normally when we have a return type that's like int or string or anything, it immediately kind of turns red and says, hey, you need to have a return statement. Well, the void keyword is what allows us to kind of ignore that error. It says, you know what, okay, even though you're a method and theoretically you should return a value, void says you're not required. It's kind of like the exception to the rule. So we'll go ahead and put the void keyword may be used as a return type. That means that no return statement is required. Which again may seem odd because the idea is that methods often, they have input, they have output. In this case, when you have a void return statement or a return type, we're saying the output may not be an actual value, it may be some action or side effect. In this case, a print to the console. And so it's arbitrary, we can always decide what's appropriate. Generally speaking, it works out in our favor to make methods that have inputs and generate outputs that can be returned, but it's not required. It's very much a style thing. In certain situations, it's convenient to not have to return something. So we're using void as our return type. So in this situation, I think we can choose, and for the examples that I have so far, they're mostly for loop based because for loops are convenient to know the limits, but we could arbitrarily make them while loops. And so in this one, we'll do with the for loop initially, and maybe we'll try to do the other ones with something different. Though again, for loops will make them, I think, much easier. So in this situation, we know that there are size rows and there are size columns. Let's assume that we don't want to print the number 0 as part of our row because normally we don't do 0 times 0 as part of our times table. We start with 1. And so if they give us the number 12, then I want to print 12 rows, 1 to 12 inclusive, and 12 columns, 1 to 12 inclusive. So let's try doing this. So we're going to make a for loop. Again, the tradition is using I and j and k as variables. So since we're going to have nesting, we're going to probably make a second loop with the variable j. And again, the names do not matter, but the tradition in code you will read all over the place, including the AP exam, I and j are very common ones. They also occasionally use m and n, but those are, again, just kind of arbitrary naming conventions. So instead of starting at 0, we're going to start at 1 because that's the first number we may multiply to get our table answer. What should be true for us to continue to iterate, and in this case to go to each row and column? It will be that I is less than the size, or the size itself. So if size is 12, we want to include it, so we should say less than or equal to. Oh, not 12, I'm sorry, size. We're being generic. Right, 12 is the example. And of course, we are going one number at a time, so we're going to do the row for 1s, the row for 2s, the row for 3s. And the result should be going up by 1, so our update will go I++. And so there's the body. The body is itself. Now, again, what we're saying is that we're going to do I is row 1, row 2, row 3. And so, for example, we might say that since I is row 1, that would be the multiplications against 1. If I was 2, then it would be 2 times whatever the next thing is. So the same thing is going to happen for columns. We should have a column, and the combination of if I is 1 and we have a column that's, let's say, j, and it's 7, then it's 1 times 7. If I is 2 and j is 5, then it's 2 times 5. So every pairing of I and j, of the outer loop and the inner loop, that itself is a cell in our grid. You can imagine that what we're generating is a table or a two-dimensional kind of spacing of content. And the answers we get are going to be related to the I and j values. So let's make another loop. Again, a for loop is convenient because we know where we'll want to start. It's going to be at 1, just like before. And again, I cannot use I because remember, the rules for the scope of variables created in the header of a for loop is they exist in the body of the for loop. And so that means that I exists throughout these curly braces, so I cannot reuse I here. That's what we're saying. So we're going to use j. It begins at 1 because we're going to potentially do 1 times 1 and 1 times 2 and so on, and continue forward. And just like before, how many times should this loop continue? And that is j should be smaller than size because we're going to also go to 12. So we're going to be inclusive, or whatever number they gave us. And then same thing, since we're going to go one column at a time, just like we went one row at a time, then we should go up by 1 each time. So j++. So if we think about what we're saying for every row, generate every column that is up to the size. So if there are 12 rows, in each row there must be 12 columns. Right? Typically when we think of columns, we suggest that it's a vertical line, but we could say our columns are really like cells. So for in the first row, there are 12 cells that go maybe horizontally, and those are each in the individual columns. And then in the second row, there's a new set of cells, and the result is a column looking downward vertically once it's complete. So the terminology is not necessarily definitive. It's much more about visualizing it. And grids or tables are a convenient way to talk. So you might hear those words a lot: column, row, things like that. And so what is it we want to display? We want to display the multiplication of those things. And so we should try printing. And we're not going to print ln because we don't want them to be on new lines. We want them to be in the same row as we're making rows. So every column in a row should be in the same row. So we're just going to use print. And what we'll do is we'll print the number, which is the multiplication, and a space next to it, so that way they're not crammed next to each other, and we'll see how that looks, and maybe we can improve it after the fact. So let's go ahead and do system.out.print. And again, the number for the current row and column is the multiplication of the value of that row and column. So if we're at row I and column j, then the value at that spot in our times table is I times j. So that's what we're going to do, is multiply I times j. We're going to display it, and then we're going to put a space. So I times j plus a space. Now, could I put this in a variable? Absolutely. But I'm not worried because the arithmetic has the precedence order. The multiplication will happen first, so there's no fear of a multiplication times a string, which would not work. We cannot multiply a number times a string. So the multiplication occurs first, and then the answer to that multiplication is concatenated with the space. And now we have to recognize when it comes to nested loops is the outer loop cannot continue to its next iteration until the inner loop completes. So we're going to see 1 to 12 if the answer number if size was 12 before we ever see I go up. So j will kind of reset itself and go through 12 loops before I even goes through 1. So I starts 1, then there's 12 loops, and then I goes to 2, and there's 12 more loops. So if we think about how many times it's actually iterating, it is much, much larger. In fact, it's the multiplication of the number of individual iterations. So if this one loops 12 times, and this one loops 12 times, then the total number of iterations, or the total number of prints, should be 12 times 12, or 144. And that makes sense because if we count the number of values in the times table of 12 blocks, then that would be 144 unique values. Now what we should be concerned with is if we're using print to make them show up next to each other, at the end of a row, the cursor must be moved down in the console, so therefore we do have to do it one extra step after the inner loop, and that is to force the cursor to go down so we can use a print with nothing in it, and that'll make the cursor go to the next line. So let's do system.out.println, and now we have two different options. If we put an empty string, that's as if we printed nothing, and so that's such a common tool to have that they even allow us to not put anything at all. So if you use println with nothing in the parentheses, then it's assumed to just put a new line character. So that's good for what we want. And so this one will have to finish, and then the next one will go, the outer one will go, the inner one will repeat itself. And so we'll have to recognize, and hopefully we've seen this in other examples, that variables declared in the scope of a loop, they get recreated every iteration. So I exists for the entire lifetime of the for loop, but j only exists for this lifetime and then is destroyed, and then when we come back around on the outer loop, a new j is created and it loops 12 times, and then j is destroyed and repeats. So this j potentially only exists for 12 loops and then gets wiped out, and then it comes back, and then I is destroyed at the very end on line 22. So local variables, the rules of local variables still apply, and so we cannot refer to j outside of this loop. If I try to use j here, it would fail because j doesn't exist. And if I tried to use I outside of that one, it would fail because I does not exist there. So let's test this. Since we made this a method, it is a static method. We can call it two different ways. We can say nested loops dot times table with a number, or because we're in the class, we can simply call the name. So let's do that in our main. We'll say times table, and then again, let's start off with 12 because that'll hopefully give us the times table that we're all familiar with. So here we go. Let's see if it comes out right. It may not be beautiful, but if it's the right numbers, and then it looks correct. So we can see that it is the grid. It's not aligned as maybe as nice as we want, but we can fix that shortly. But notice 1 times 1, 2 times 2, 3. So if we look at it, we can say 3 times 4 is 12, right? 5 times 9 is I'm sorry, I mixed. So it's actually supposed to be a little bit further, so 5 times 9 is 45, but they're misaligned. So let's fix that, and this is something that we can talk about. And this is not an AP exam, but it is a convenient thing to know. There is a third print statement that will give us a little bit of control. And I know some people may have seen this on their own kind of research, but we have print and println. There is a fourth option called printf, and this is tied to the classic language C and C++ that have the printf command. And the way printf works, so I'm going to temporarily comment this out. So if we say system.out.printf, the way it works is we give it what's called a format string, and then we pass in data. So what we're going to say is, and we'll just type it out for now, the format string, we put kind of placeholders. So what I'm saying is we're going to replace something and not with a number. So %d means there will be a whole number that will be replaced at some point there. And what's nice about placeholders is that we can add extra features to them. So in this case, we're saying, well, it's going to be a whole number, but I want it to take up 4 spaces no matter what. So if I gave you the number 12, 12 is only 2 characters, not 4 characters. So what it's going to do is it's going to put empty characters in front, spaces, and then push them over. And that makes it line up. So we can get a right-aligned grid very easily by using this. And so I choose 4 because I'm comfortable with the idea that this grid, if I go to 12, will not go too big. But if there are more than 12, if the multiplications end up giving us more than 4 digits, then maybe a bigger number would be appropriate. And then after the format string, we put what's going to be replacing that placeholder. So what value should be replacing this thing? And the answer is the same that was here, I times j. So let's go ahead and put that. And a semicolon. So this is saying, hey, every time you display something, you're going to give it a whole number, and it's going to always take up 4 spaces. And leading spaces, what they are blank if we don't have them. Now, if you have a number like the number 1000, then all 4 spots would be taken, so you would have no leading zeros. Since we're using 12, we're comfortable that the largest number we're going to get is 12 times 12, which is 144. So we should have at least one gap between them. Now, I should maybe add an extra space. So I'll put a space after it, and that'll be a literal space. So some of them might look like they have 5 spaces, but the idea is that there's always an extra space just in case. So let's run it and see what it looks like. And that's a nice formatted grid. And so again, the idea of printf, it says, well, I need to take up 4 spaces, so let's look at an example. The number 35, it's not just the number 5. In reality, it's 35, 1, 2, that's 2 spaces, 3, 4 characters, and then there's an extra character, right? And then 1, 2, 3, 4, and then an extra space, and then 1, 2, and so on, right? So, and then now if you look at 144, one character, 2 characters, 3 characters, 4 characters, and then this previous character is the space from there. So that's those 5 characters. And so that's the idea that we're using this to be right aligned. If I believe we put a dash in front of the number, instead of putting the leading spaces, which makes it right aligned, it actually makes it left aligned. So if I put -4 or -4 and I run the same exact printf, now we see that everything is left aligned. So now if we count it, it's 1, 2, 3, 4, and then the 5th space. So on this example, 1, 2, 3, 4, and then the 5th space, right? So that's convenient. And here it's 1, 2, 3, 4, and then the 5th space. So either way is acceptable. This is a quick way to do grids. Now, again, I'm going to really quickly show how it can go wrong, or at least it won't look pretty, because if I make the table big enough, if we do up to 20, so 20 times 20, we might get digits with 4 numbers, and that could be a problem. Actually, no, it's got to be much larger. So it still works out because nothing's above 400. So let's do like something like, I don't know, 100. And now this is going to be a huge grid. And in fact, it's so big that it actually took a little bit of time to print. And notice what happens is that there's more gap between these because there's empty spaces and there's less gap. And so the biggest numbers work out nicely. But what I'm going to say is if we made it a little bit bigger, then we might end up having no gap at all because, or only one at most, because they're going to start to fail lining up because they take more. So typically, the number we pick here, we pick a number that we're comfortable that will be unlikely to be oversized, something that won't go beyond it. So going to 100 is maybe not safe because we only figure we're going to have 4 characters at most, but 100 times 100 would be 10,000. So this does seem to work, and it is with nested loops. So this is a very convenient tool to have, right? And there it is. And the printf is just a kind of an extra fact that allows us to align things nicely, right? Okay, so let's try another example. I hope this makes sense. And the next example is very similar, but and unfortunately, as similar as many of these solutions are going to look, it's always about the context. Sometimes things change. There's subtleties. In this example, I started with 1 and ended with, I used less than or equal to. We might have started with 0 and used strictly less than. Or we might start backwards. There's all kinds of scenarios that might work, and we'll see in our next example with the pyramids that it could cause issues, and we have to be very careful about how we do things. So let's make another method, and this one is just going to simply print the left-aligned pyramid. So let's make a method. It's going to be public because we all want to use it. Static because the only context is the data we're using. Void because we're going to print. We're not going to return anything. We're just going to print out our pyramid if we can. And we'll call it left triangle. I'll call it triangle, not pyramid. So left triangle, because it is a right triangle. And then we'll tell it, well, how many rows do we want in this triangle, right? So let's go ahead and say int, I'll call it the height. So the idea is going to be, if you're in the first row, so let's say the height is 5, then in the first row there is 1 asterisk. If you're in the second row, there are 2 asterisks. If we're in the third row, there are 3. So then the row corresponds with how many items there are. But we need to print them individually. We can't necessarily, Java's not a language that lets us quickly generate a string except with a loop. So we need to build up a loop or do something like that, or print multiple times with a loop. So we're going to have one loop that manages which row we're on. And then the inner loop, the nested loop, will manage the printing of the correct number of asterisks. So that's the idea that we're going to have here. And again, since we know the height, we know where we start, we know where we end, and so for loops, again, are the better choice. I could do this with while loops, but again, I think that we can try this with for loops, and it's a convenient approach, a little bit easier this way. So we'll say for int I, And now, whether I start with 1 or 0 is arbitrary. We should be just comfortable. I'm going to try it with 0 just to kind of force us to think about some of those edge cases and scenarios where it's very common that mistakes occur. So we're going to make I equal to 0. Our condition will be is strictly less than the height. This is very much like a string, because if the height is 5, then the numbers 0, 1, 2, 3, 4, that's 5 different numbers. So that's the correct number of iterations, 5 rows. So we're going to say I is less than height. We could start at 1 and include height. That would also be acceptable, but I'm doing it on purpose with the 0 just to get us comfortable with that idea. And then we're going up because we're doing 1 row at a time. So I++ is a very common update result. Now this is which row we're on. I is the row, so if we're on row 0, that's the first row. If we're on row 1, that's the second row. If we're on row 4, that's the 5th row. And that'll be the last row in our example, if the height was 5. So now, if I'm in a row, I want to loop the same number as the rows I'm in that many times and print out asterisks that many times. So a for loop is convenient because I know where I'm starting and I know where I'm ending. But let's try doing it with the while loop, just because it's an interesting problem to do. So we'll say, okay, we're gonna use a while loop, so we're still gonna need a sentinel, we're still gonna need an update, and we're still gonna need a condition. It's just gonna be structured differently. So let's make a variable, and we'll call it. And so since we're not doing a for loop, I might not use j. I could use j, but I'm gonna make a different thing. We'll call it I don't know. Let's think. Ooh, that's hard. So which star we're on. So their asterisks are like star, so we'll say star. And again, what we'll do is this time around we'll initialize it to 1. So we're on the first star. And so what should be true about the star value that tells us that we're still printing asterisks? So if I is 0, that's the first row, we actually want 1 asterisk to show up. If I was 2, that's the third row, so we'd want 3 to show up. So hopefully we can see that whatever number of times we're going to loop, it's going to be 1 more than I. If we started at 0, or we're going to include it if we start with 1. So our condition will be while star is less than or equal to I plus 1. Right? And that way we get, if the height is 5, the last row should have 5. Right? So we can do an example, we can print it, and if it doesn't work out, we can kind of debug and figure out if our arithmetic is wrong, but I think that we might be okay in this scenario. So what is our work? Printing out the asterisk, 1 asterisk, and then updating our star. So let's go ahead and say system.out.println, but not println, just print, because we want them next to each other, and we're printing a literal asterisk. And then because there is no automatic update for us like the for loop, we must increase our star by 1. And there it is. And so this loop, again, the same rules apply. I will not change until this loop completes, right? We cannot leave an area until the loop is finished, and then the next loop will recreate. So star gets destroyed and recreated every single time the outer loop does it. This is not the same star, and that kind of makes sense because if we're declaring it, it must be that there are no conflicts. So each scope is a different scenario. The star is technically a different variable in RAM as this happens. Now let's see if this works. It might be off by 1 because of this arithmetic, or it might be correct. So we're going to call this in this print. So I'm going to comment out times table, and this is what's nice about making methods is now our main is super small, and so let's call left triangle, and let's do it with 5. And let's see what it looks like. Oof, I missed one giant thing, and that's definitely not, that's just a line. And this is actually the same problem that we had with our grid, with our times table. After the correct number of stars on one row, we need to make the cursor go to the next row. So we should print out nothing. So that if I printed 3 stars and the next one's going to be 4, it's going to be on the next line. Otherwise, they end up all next to each other because prints do not put new line characters. And now let's see what happens. See if this is better to what we want. And there it is. And notice, first row has 1. The second row has 2. The third row has 3. The fourth row has 4. And the fifth row has 5. Now, let's go ahead and pretend that I didn't do this I plus 1. It was just I. and we're going to see what the result is going to be. It's going to be almost look like it's good. And it looks sort of the same, but we'll notice a difference. First of all, there's a blank space on top, so it's like it was pushed down. It wasn't really pushed down. And notice that if we actually count this, there are 5 rows, but the last row has 4. The first row has 0. I was 0. That's the first row. The second row had 1. The third row had 2. So it's off by 1, and that's exactly what we did. Is we took away 1, so it was off by 1. So one fix is to do what I did, the +1. Another fix may have been to start at 1 and include height. And let's see if that fixes it. And there it is. Notice there's no space on top. The first row has 1, the second row has 2. And so is there a right way? Absolutely not. It's about style and choice. Often we see, the reason that starting at 0 is such a common practice is because often we manipulate strings, and we know strings are 0-based indices. And when we get a little bit further, we'll see a structure called an array, and they are also 0-based indices. So it's very common for comfortable programmers to use 0 as a starting point. But the risk is we often cause these off by 1 errors. So we have to be very, very careful about those things. And so I'm going to leave it how it is now. I can get rid of these parentheses. So since we started at 1 and included height, that kind of matches our brain. Oh, row 1, row 2, row 3, row 4, row 5. As opposed to row 0 goes to 1, row 1 goes to 2, row 2 goes to 3, and so on. So I think this is a good example. Now, what I'm going to do is I'm not going to do the last one. I wanted to, but I realized maybe this is a good practice for you to try out. Can you generate a triangle that is not left aligned, but right aligned? So it's spaces, and then the first one is still, so it's still pointing up, still starting from small to big, but they're all shifted to the right. And I think that is a little more challenging than we might believe. I would say if you're going to try to use printf, don't do it. Try to do it with just regular prints and printlns. And the hint that I gave at the beginning, I think I can repeat here, is you printing spaces, depending on where you are and which row you're on, could be very helpful. So I think I'm going to end the video here, and I think that it's a good challenge to try to print this triangle but right aligned. Make that method, call it right triangle, and then with the same input, and see if you can get it to show up and print nicely as our example does. And again, the bottom line to take away from this video is we can nest loops, and there's no limit except the amount of work that gets done could be a lot. So if we actually counted, well, how many stars did we actually print? With 5, we didn't only print 5 times, we printed what? The first time we printed once. The second time we printed twice. The third time we printed 3 times. The fourth time, so it's actually the multiplication. If you think about it, it's going to be this 5 times these 5. So the result is 5 times 5. There are 25 prints, and we can prove it by if we count the number of asterisks. There should be that many, right? Or that many prints. That's what it is. And so that's the idea. Okay. Oh, sorry, it's not 25. It's a little bit less than that. But that's the idea, that we're looping that many times, and we have to be very careful about what we're doing here. So I'll end the video here, and we'll continue in another video. I'll see you in that next video.